Welcome back, everybody, to a second screencast on the topic of measures of spread. In this one, I promised we would look at two things. One is z-scores, and the other is outliers. So for z-scores, what we'll do is we'll look at a concrete example prior to defining z-score, and then we'll use it in a latter example. So let's consider this particular list of marks again from the previous problem. So here is that data set above. So we have a set of 20 marks ranging from a minimum of 17 to a maximum of 40 with a median mark of 30. So in this particular problem, we're being asked how many standard deviations is a score of 36 from the arithmetic mean, okay, and then also a score of 25. So in order to figure that out, we would need the standard deviation. And to get the standard deviation, we have to have the arithmetic mean. Okay, so let's do that. That's our first step. So you can see I've recorded both relationships. So a basic formula for both mean and standard deviation, and have gone ahead and calculated it. So at this point in time, we won't go through the step-by-step nature of how to figure out each of these, as it's rather tedious, and we've gone through that. But I would suggest that for the purpose of this video, and also to increase our efficiency, if you do have access to spreadsheet technology, okay, so we can go online, we can find an online statistics calculator. We can also use Microsoft Excel, and that's what I'm showing you here. So you can see that I have listed my data here in column A. So I have 20 pieces of data. And here below, highlight that, you're going to see here in my formula bar that I'm calling this the STDEV, or the standard deviation. And then in parentheses, I'm indicating the range. So you can see the range of values being used, being highlighted in blue. And then upon clicking enter, I would end up with the standard deviation. When using Excel, if you haven't done that before, for formulas, you have to indicate an equal sign. So make sure that that's there. So we have a standard deviation. To two decimal places would be about 6.57 in terms of points on this test. You can also use Excel in many other ways. So we could use it to calculate the average. So equals average, highlight those values, press enter, and there you have your average of 29.15. I believe you can even calculate the mode as well as the median. You can see that these formulas are popping up as we go through. And just for the sake of doing this, let's calculate the median, and we know the middle datum is 30. So there, very quickly, if you have a small data set, you can easily dump that into Excel. If you have data that you're pulling off the web or from some other document, if you can copy and paste that data or import it into Excel, a large set of data doesn't become that big of a deal in terms of calculating the measures of spread as well as the measures of central tendency. So let's head back into the lesson document, and we have these two values here. So in order to find out how many standard deviations 36 is from the mean, we have to expect that that number is going to be a positive number because it's going to be above the mean. And 6.57, if we just do the math on this, a little mental math, let's say that's about 6.6. Okay, adding that on to here, we're getting around what, say 36 in terms of a score. So if we go up here, 36, right, that particular score, what we're saying is that relative to where the mean would be, so 29.15, we're looking at a full standard deviation. Okay, so most of this data, at least the upper end, and of course the lower, are being captured by one standard deviation. So let's have a look at a formal calculation. So we'll take the desired mark, we'll subtract it from the mean, so we know its deviation, so how far is it from the mean, and then we'll divide it by the size of the standard deviation, and that'll tell us how many standard deviations it is, in this case above the mean. So we have positive 1.04, and that 1 is telling us it is just slightly more than 1 standard deviation above the mean. Similarly, a score of 25 is below the mean, so subtract the mean from the score, gives you a deviation, divide by the standard deviation, and it's about minus 0.63. Okay, so about 6/10 of the standard deviation, but in terms of the negative, indicating that it's below the mean. So that, in a nutshell, is the concept of z-score. Z-score will then come up in the next little while when we start studying what is called the normal distribution. And last but not least, let's take a look at the concept of, actually we're still working on z-scores here. I'd forgotten we hadn't defined it, but through the example we do have a definition. So it's the number of standard deviations from the mean, and your formula, as was modeled using some concrete values. So Z for z-score would be equal to the value you're looking at from your data set, or X, subtracting the mean from it, and then dividing by the SD, or standard deviation. As far as follow-up is concerned, here's an example. It comes in 4 parts. So using the stats in this particular table for 4 different distributions, we're going to tell which ones have positive z-scores, so z larger than 0, or those that are negative, or z is less than 0. So we're at a really good point in the video now where it would be great for you to pause and just take time to think about the values you're given, and then start answering A, as well as B. And for all intents and purposes, you could even go through parts C and D, and then play the video from then on. So as far as positive and negative standard, z-scores, you can see that I'm representing symbolically. You could do it numerically, but in writing that, the value of X, which is 45, is larger than its mean, which is 38. That implies that the z-score is greater than 0, meaning that the z-score is positive. So the value of 45 lies above its average by so many standard deviations. So if you go through the list, kind of check it out. So B is a negative z-score, C is negative as well, part D is going to have a positive z-score. As for part B, I'm not writing anything down here, but it has been stated previously that it tells you how many standard deviations a datum is above or below its mean. So part C and D, I've got these below, and you may have already gone through and calculated the z-score for row B, so you can check your work here. That z-score is a -1, and I would highly recommend that before you calculate, take the time to process if you believe it's above or below. That is, will Z be negative or positive? And by doing that, if you do make a minor calculation error, you'll be able to pick up on that right away, as you'll be trying to justify whether or not your answer makes sense. Now, part D, if you're going to have a z-score of 0, that means you're not counting any standard deviations above or below the mean. So basically, we're looking for the average. Okay. So formally speaking, if I were to substitute 0 in for Z, the only way for that to be true, that is to get an answer of 0, is if the numerator, x minus x bar, that is if the deviations were 0. So if we set that difference to be 0, the only way to arrive at that is if the x value you're looking at or considering is actually equal to the mean itself. And by doing that, you'll end up with an x minus x bar of 0 and that particular fraction or relationship producing 0 as the set score. So looking at our time, we're already up to, again, it's 10 minutes. It's amazing how long the video can go on. So I'm thinking, again, let's cut this one off here, and we'll package the final video into a third lesson on outliers.